Right, welcome to 7.3, which is simplifying radicals. So you're going to see a radical. It's going to be looking something similar to what I have right here up top here with the A. The A is going to be called the coefficient in front of the radical. So this is a coefficient. The I means the type of radical, so this is called the index. So if there's like 3 there, then it's a cube root. A 4 there, it's a fourth root. If there's nothing there, so this is a square root, so if there's no number. If there's a little 3, then it is a cube root. If it is a 4 there, no, we don't have anything special to say, it's just a fourth root. Oh, I think I spelled that wrong. Fourth root. What's underneath the square root, or the radical, is called the radicand. You might not hear that too often, but in case you do, what's underneath the square root is called the radicand. And now, in order to simplify radicals, you must be able to write the radicals, the radicand, or you must be able to break down the radicand into prime numbers. That's the first thing we need to do. Every number needs to be broke down into a prime number. So write as a product of a prime number for the next one. So what I'm going to do is you think, what two numbers multiply to 24? So it doesn't matter which two you choose. That's the cool thing about these prime numbers. You can choose anything. I always choose, if the number ends in an even number, I always just divide by 2. So 2 times 12. I circle my prime numbers. Prime numbers means only 1 times itself. 2 times 1 is the only way to get 2, writing with whole numbers. 12 does not a prime number. There's 12 times 1, but then there's also 6 times 2. So 2 times 6. 2 is a prime number. 6 is not, because there's also 2 times 3. 3 is a prime number because there's only way to get 3 is 3 times 1. All right, so now I'm going to write out my prime numbers, the one I circled. I have 2 times 2 times 2 times 3. And there is 24 written out in prime numbers. 2 times 2 times 2 times 3 is 24. Let's do 220. So again, it ends in a 0, so I know it's even, so I know it's going to end, it's going to divide by 2. 2 is a prime number. 110 is 55 and 2. 5 doesn't end in, it's not an even number, so it doesn't divide by 2, but it'll divide by 5. It ends in a 5. So that's 11 and 5. 5 is a prime number. 5 times 1 is the only way to get 5. 11 is a prime number. 11 times 1 is the only way to get 11. So I have 2 times 2 times 5 times 11. All right. If we can do that, we can figure out how to simplify these radicals. So here's our steps. So we are going to use a factor tree. Whoa, these are called factor trees. Those are factor trees. Use a factor tree to find the prime factorization, the prime numbers of the number under the radical of the radicand, which is the number under the radical. Next step, use the index to determine how to group the factors. Next is to, for each group, one factor is going to leave the radical. And I will explain that more as we're working through. Leave underneath the radical. Lastly, multiply the outside factors together and multiply the inside factors together. So that is our last step. And again, when we see these examples, I'll be able to explain all these steps. And I'll try to do it in the color that I wrote the step in. So, first step is use a factor tree to find the prime factorization of the radicand. So the radicand is 24, so that's underneath the radical. And we're going to break it down. It does not matter how you break it down. Again, I usually do 2, and if I can divide by 2, I do 2. 12 is 2 and 6, 2 and 3. So now when I'm looking to, I'm going to write it horizontally, 2 times 2 times 2. I kind of group everything together. It is a square root. This is a square root. So now we're going to use the index. Then step 2 is what kind of radical is it? This is a square root. We don't write the 2 there, but that's a 2. This is going to determine how to group the factors. So we're going to have groups of 2. So this is groups of 2. So we're going to take our prime numbers and group them in groups of 2. Well, we have 2 times 2. That's the only group I can make. For each group, so now for number 3, for each group, one factor is going to leave the radical. So that 2 is going to, for a group, one of those factors is going to come outside. Really, it's 2 times 2 is 4, and the square root of 4 is 2. So 2 times 2 is 4, and if you square root 4, that's 2, and that's why a 2 comes out. And then lastly, the very last step, that's the only grouping, so that's the only one I have to worry about, is to multiply the outside factors, so there's no other outside factors, so it's 2 times the square root, and the 2 times 3 is left over, so that's 2 times 3. That's going to come down. So 2 on the outside, 2 times 3 on the inside is 6. So the square root of 24 simplifies to 2 square root of 6. All right, let's break this down again. The next one, 220, 2 and 110, 2 and 55, 5 and 11. There's our prime numbers. Group them, group the numbers. Then we're going to, so we have grouping. Oh, it's a square root, my bad. Square root. So we're grouping by 2. There's only one group that I can make up. That one group is going to come out. And only one is going to be written out. So 2. And what's left over is the, so it's multiplied. It's a square root. 5 times 11. That's 55. So we have 2 square root 5 times 5. 5 times 11 is 55. So the square root of 220 simplified. And the reason why it's simplified is underneath the square root, that's a smaller number. All right, number 7. 96. That is 48 and 2. That is 24 and 2. 12 and 2. 6 and 2. 3 and 2. Sometimes these factor trees can get pretty long. I'm going to write out, I have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. And then there's 1, 3. We're then going to look at grouping. So our next step is to group. So we have a square root. So it's grouping of 2. So 2 and another 2, and that's it. So a 2 is going to come out. Another 2 is going to come out. Those are going to be multiplied. And the 2 times 3 is going to stay underneath the radical. It's the square root, so it's going to be 2 times 3. 2 times 2 on the outside is 4. 2 times 3 is 6. So 4 squared is 6. So the square root of 96 simplifies to 4 squared is 6. All right, 135. That ends in a 5, so that's 27 times 5. 5 is a prime number. 27 is not. That's 9 times 3. And then 3 times 3. I'm going to write this out. We have 3 3s and a 5. Looking at what kind of radical it is, it's a 2 square root, so it's pairs. So that 3 is going to come out. And the 3 times 5 does not have a pair, so that's going to stay underneath the square root. So we have 3 times 5 is 15. And that is it for simplifying radicals just with